Cells EMF, internal resistance and terminal voltage. Usually EMF considered to be voltage across the terminals of the cell, but that is a wrong notation. Whenever a cell in an open circuit, then the voltage across its terminals is said to be electromotive force. Consider a cell with a positive, negative terminals. Across these two terminals, what is the voltage lies? That is known as the electromotive force of the cell. Then voltage across the terminals of the cell, that is equal to EMF. But when a cell it is in a closed circuit, and assume the current flowing from negative terminal to the positive terminal. Cell with positive and negative terminals. Assume that the current flowing from negative terminal to the positive terminal. In this situation, voltage across the ends of the cell of internal resistance, let it be R, E is the EMF across the ends of the cell, then the terminal voltage across its ends, that is V is equal to E minus I into R. Whenever cell in a closed circuit and the current flows from positive terminal to the negative terminal. Assume that the current flowing from positive terminal to the negative terminal in the reverse direction as shown in the second case of the EMF E and the internal resistance R, then voltage across the terminals of the cell in this situation, that is E plus I into R. Cells in series with an external resistance. Consider two cells of each EMF E1 and E2 of internal resistances R1 and R2 connected in series with an external resistance R. As cells connected in series, same current flows through the circuit. Now let's write the terminal voltage across each cell. Voltage across the first cell, terminal voltage V1 is equal to, as current flowing from negative to positive terminal, that is EMF across the first cell minus I R1. R1 is the internal resistance of the first cell. Now the terminal voltage across the second cell, that is E2 minus I R2. R2 is the internal resistance of the second cell. Then terminal voltage across the two cells, I mean A and B, across the terminals of A and B, that is equal to terminal voltage across first cell plus across second cell. Terminal voltage across the two cells, that is equal to the voltage across the external resistance, that is equal to I into R. Substitute the values of V1 and V2. E1 minus IR1 plus E2 minus IR2. That is equal to E1 plus E2 minus I of R1 plus R2. Rearrange the terms. IR plus I of R1 plus R2 equal to E1 plus E2. I taking common, R of R1 plus R2, E1 plus E2. Then we get an expression for the current in the circuit. I is equal to E1 plus E2 by R of R plus R1 plus R2. This is an expression to find the current. Now let us take this can be modified for the case 1. If two cells are identical, with internal resistance R, formula it modifies. I is equal to E plus E as E1 equal to E2 equal to, let it be E, and R1 equal to R2 equal to R. Then it is R plus R plus R. It gives the final expression I is equal to 2E by R plus 2R. This is an expression for identical cells of internal resistance R.